thank you so much. This is a big pleasure to be here. The event so far has been great, and hope you guys enjoy my talk. So I'm Jorge Antonio, CTO and co-founder of Automa Network, and I'm talking about what we are building at Automa, the decentralized hyperscaler for open source AI on Sui. So before I start, I would like to ask the audience, who here has interacted with ChatGPT today? You can raise your hand. Yeah, I see a few hands up. Awesome. And who here also believes that they are sharing too much personal data that they will prefer not with OpenAI? She'll see a few hands up. That's great also. All right. So I will start by sketching like the opportunity here. So here I have a graphic showcasing like the open source versus closed source model capacity, right? And we can see that open source models have been able to catch up really well with like the best in town, like closed source models. So for example, Llama 4, DeepSeek R1 are almost as good as, let's say, GPT 03 or Grok 3, Claude 3.7, Sonnet, etc. So there is a big opportunity lying around like deploying these large language models in the open source space. That said, open source AI has an infrastructure problem, right? So there are two solutions right now. The first one is you have a local hosting of these models. So basically on-prem deployment. This introduces some challenges, including like technical skills. It requires a lot of technical skills to deploy these models at scale, right? It has a high capex, meaning that the cost to deploy these models locally, the infrastructure costs, the hardware, the GPUs are pretty costly, so you have to spend a lot of money to have like a local deployment for you. And then, of course, it's not scalable. Every company has to make their own like hardware deployment, which is a big burden, right? On the other hand, you have cloud service providers, and these have also a few challenges. So they solve some of these problems around high capex, the scalability issue, but then they don't have privacy. So when you interact with these large language models, you are sharing your data, your personal data, in plain text with these providers. And for us, like, let's say, retail customers, some people might be fine with it, others might not be. But if you think at the enterprise level, institutional level, governmental level, you need to protect your intellectual property, your customers' data. And now privacy becomes actually pretty relevant, right? So I already mentioned why privacy matters in this context for AI to unlock the true potential of AI. It basically increases the trust. So now, for example, let's say that you are a healthcare company, financial company, etc. If you have privacy, data privacy, when interacting with these large language models, this basically will open the doors for many more applications, many more use cases being built on top of it, right? You have sensitive data protection, which is pretty crucial for a lot of use cases and customers. And one thing that I'm particularly excited is hyper-personalization. So it will be ideal that these LLMs will know everything about us, the LLMs, but not the LLM provider, right? That's a big distinction that we need to make. So if I'm sharing all the context of my life, including like, let's say my healthcare metrics, my financial reports, my taxes, my dating life, my friends, all these things, I would rather keep that pretty private, right, for myself. And that can lead to hyper-personalization. If we share these, LLMs will have more context to interact with us, and they will help us quite substantially improving our lives. All right, so Automa is basically tapping into this opportunity to provide like open source models at scale with data privacy, leveraging the Sui blockchain, and become like a decentralized hyperscaler, right? So as I mentioned, the big opportunity is serving these open source models applications at scale. And with privacy, which is cost efficient, we don't want to pay like 10 times the market price to have privacy. I think everyone agrees. We want to be competitive with any open source or any like LLM provider out there, and we need the scalability. So here I have a diagram about the Automa network design. I will be pretty quick on this, but it's pretty modular. We use the Sui blockchain as the coordination layer for resources, for GPU nodes registration, for security guarantees, for the transparency. And we also use Walrus for storing data, user data, in encrypted format that can be basically used to provide more context to LLMs moving forward. So you can have this hyper-personalization being achieved on the LLM side with Automa and on the storage side with Walrus. So here I'm basically showing you how we can compare different privacy and verifiable technologies. One thing I haven't mentioned yet is verifiability, which basically pertains to ensure that the execution, the LLM model running on your data is run, like the execution is verifiable, is correct. And you have a bunch of different approaches. One of them is TEs, trusted execution environments, or confidential compute, which is technology we leverage on Automa. This is great because it gives you confidentiality, verifiability, and has minimal overhead, right? And TEs, they might not be the best technology for deploying a blockchain where you have billions of dollars at stake, but they are great for LLM applications and AI applications as a whole. Then you have the on-prem solutions, which I already mentioned, ZKML, which is great for verifiability, is non-confidential, but has a massive overhead. And FAG, we are still a few years away and has still a very massive overhead as well. So how Automa works, like in a simplified manner. So you are a node, meaning that you have, like you might be a data center, compute provider, you have some machine with some GPUs, you can connect on the Automa contract on the Sui blockchain, doing some registration, you submit some trusted execution environment remote attestation that can be verified, and you bound to it some public key. And this public key is a public key that allows to have shared encryption between the node trusted execution environment enclave and the client. So later on, the client, when it wants to send a request to Automa, following, let's say, the standard in the industry, which is the OpenAI API standard, the client just needs to create a request, OpenAI API compatible request, encrypted with the node shared encryption key, and send it to the node. And this will only be possible to be decrypted within the trusted execution environment of the node. So that guarantees that not even the node operator can access the data within the request and the response. So basically the client and the node, they have like a secure remote attestation TLS channel. So Automa, we have made some great progress in terms of confidential compute. We are the first network or the first project that has unlocked full confidential compute for any size model. So to deploy these AI workloads with confidential compute, you need to have both the CPU and the GPU trusted execution environment enabled. And importantly, you also need to guarantee that the communication between CPU to GPU and GPU to GPU is fully secure. And we have achieved this, and very few projects have this. I think right now, at the time we speak, Azure and Google are like basically centralized alternatives with confidential compute. So Automa is optimized for scalability. So we have, of course, we are using the Sui blockchain, which makes everything much more scalable just by the Sui consensus design and the Sui technology as a whole. But we have very efficient payments where we have an approach to sort of like aggregate or batch payments together, which makes the scalability of the network much higher. We have very smart routing for node selection, meaning that clients, they can select the best nodes on real-time metrics and interact with these nodes directly. So we have minimal overhead in terms of like node selection, etc. We have a synchronous middleware, and we have very good performance around time to first token, time for output token generation, etc. So how this decentralized hyperscaler looks like? What's the supply look like? So basically, Automa is gathering basically compute providers and nodes across the globe. It includes the US, Europe, Asia, and the Middle East, and some zones in Africa. And we have roughly $100 million committed for mainnet of compute supply, which is really exciting. So a few words about the ecosystem. So we have really deep partnerships with some key projects in the space. We are, of course, partnering with the Sui blockchain, with Linera, which is another blockchain. We also have partnerships with LLM gateways and aggregators, OpenRouter, Light LLM, etc. We have also integrations with agentic infrastructure, Talos, ELIZA OS, etc. So basically, agents can tap into the LLM execution of Automa and guarantee that these agents are running, or the LLM execution is being run without being tampered in any way or form, and with privacy, which is important for MEV situations, right? That can be some sensitivity around that. We also have seen some projects working or building with Automa on the DeFi and financial landscape. Navi, Sphere One, Aftermath, to name a few, on the Sui ecosystem, the gaming and social anomalies, Studio Mirai, etc., AI apps in Ifra, Utopia, which is one application built by the Automa team, Open Graph, etc., and you have also compute providers, including like Ori, Atai, etc., and a few others, Walrus, Tusky, and a few other projects. So to highlight a few of these partnerships, with OpenRouter, we have already we have launched our DevNet, and OpenRouter is leveraging Automa to provide like inference at scale, and it's actually generating real revenue to the network, to Automa, still in DevNet stage, which is pretty exciting. And then we have integrations with Linera, where Linera nodes can interact with Sui through their client, SingularityNet, Fetch AI, Anomaly, and a few others. And yeah, that's it. Thank you so much.